Hey, these are your lecture notes for tonight in Chapter 9, so you should be writing these down just like you would write them down in class. We previously had Roman numeral 1, that was some vocab terms, and Roman numeral 2, that were your practice problems. So Roman numeral 3 is moles and equations. Here's the term that we used in class today, the mole ratio. Remember, the mole ratio is taken from the balanced chemical equation. So once you have your balanced chemical equation, all these coefficients, when nothing's written there, it's 1. So coefficient in this case of 2, 1, and 2, those coefficients can become conversion factors. Remember, conversion factors can also be flipped. So in this case, you could also put the 1 O2 on the top and the 2 moles of hydrogen on the bottom. Okay, what this screen is. This screen gives you the steps for the problems that we did in class today. So if you get stuck on homework page 2, you can choose either option A or option B to give you the steps of how to go through something. Now, you do not need to write down both of these. Choose which option works for you. They're the same instructions. For example, option A, when you take the grams of what you start with, go back one. When you take the grams of what you are starting with, you then convert grams to moles. Here in option B, it tells you convert mass, which is grams to moles. So these are the same steps. Option A is simply for people that like to read things left to right. You can see each step, you just arrow to the next one. Option B is for people who like to read, here's my step number 1, 2, 3, 4, and go down that way. So choose which option works for you and record either option B or option A in your notes. Okay, now the next topic is called limiting reactant. We're going to begin a lab, and again, this uses equations and calculations that you've already learned, but the vocabulary that goes along with it is different. I've given you an example of this in class when we talked about it previously. When you're given the two reactants, the limiting reactant is the reactant that's used up first. For example, I've got the Oreo cookie in the picture. An Oreo cookie takes 2 cookies and 1 cream. If you were making Oreo cookies and you had 5 wafers and 2 creams, you could still only make 2 full Oreos because you would only have enough wafers and cream to make 2 full cookies. Excess reactant is what's left over. Limiting is the one that stops the reaction. The limiting reactant is used to determine what's later called your theoretical yield. Okay, so here's what your theoretical yield is. Your theoretical yield is amount you can calculate both on paper and back in the laboratory, the amount of product formed when all of the limiting reactant is used up. Here's the key part. You use the limiting reactant. So limiting reactant will be in grams, and this will be in grams. Your limiting reactant might start in moles, but then you'll have to convert it to grams, so final result will be in grams. Especially in a laboratory situation, we can't use moles in the lab, we have to use grams. Here are the steps that go through using the limiting reactant to find the theoretical yield. As always, number 1, balance the equation. Number 2, you're going to convert the grams of both reactants to the grams of the given product. This is a sequence of steps we've already done. Grams to moles, then your ratio of your moles, and then moles back to grams again. You're going to find out which produces the least. Which of the reactant produces the least product. That will be your limiting reactant. Again, we will go through examples in class. This is just so you can get it and refer back to this in your notes. The reactant that makes the most product is the excess reactant. So there will be some reactant left over. The excess reactant is what is left over. The limiting reactant will be all used up and stop the reaction. So I kind of like the peanut butter and jelly sandwich almost better than the Oreo idea. If you have just 3 pieces of bread, you cannot make 4 sandwiches because the bread will limit how many sandwiches you can make. If you have a full jar of peanut butter, your peanut butter will be the excess reactant and your bread is the limiting reactant. The limiting reactant will determine the theoretical yield, and again, in a lab situation, that theoretical yield will be given in grams. Percent yield would be a laboratory situation. This will be the last slide for right now, where you take the actual yield that you calculated in the laboratory and divide it by theoretical yield times 100. You actually have done this even when the very first labs of the year you had calculated percent yield. That's all for today. We'll have more practice in class.